Hi friends, in this video we learn about Cauchy's residue theorem. So let us see this. If f of z is analytic at all points inside and on a simple closed curve C, that is very important, all points must be lying inside the curve C. That is very important, right? Except at a finite number of poles z, z1, z2, zn within C, then closed integral f of z dz is equal to 2 pi I into sum of residues of f of z at z1, z2 up to z, right? So this is what Cauchy's residue theorem, right? Okay, we don't go and elaborate and find the proof. We will directly apply this theorem to the problem, right? So first thing is f of z is analytic, so this is the condition. This is a theorem, right? In the problem, all the f of z they give is analytic only, and we have to check whether the points are lying inside the circle or inside the curve or outside the curve, right? So that is very important. This equation represents Cauchy's residue theorem. So closed integral C f of z dz is equal to 2 pi into sum of residues of f of z at z1, z2, zn, right? The answer we get for this integration is same as what we got in by using Cauchy's integral formula. For any problem, if you apply Cauchy's residue theorem and the integral formula, both will give the same answer. I already posted one video on Cauchy's integral formula. The same problem only I have taken. So before watching this video, please watch my video on Cauchy's integral formula. After that, you see means I have taken the same 6 problem I have explained in the Cauchy's integral formula, and we get the same answer in both. Let us see that. The first question is evaluate integral c dz 3z minus 2, where c is the circle mod z is equal to 1, right? So what is the question? 3z by z 3z minus 2. Here we are going to evaluate by using Cauchy's residue theorem. If you evaluate by using Cauchy's integral formula also, you will get the same answer that I have posted in the some other video. This is what our question. What is Cauchy's integral residue theorem? C f of z dz is equal to 2 pi I into sum of residues, right? So first I have to find the residues of f of z, then I apply this theorem. So what is f of z here? This implies f of z. Compare these two equations. F of z is equal to 1 by 3z minus 2. This is what my f of z. How to find the residue? Residue, first if you want to find residue, it must be in z minus z naught formula. So I take 3 outside, it is z minus 2 by 3, right? So what is the pole? It is a pole of order 1, right? It is pole of order 1, simple pole. So pole at z is equal to 2 by 3. If you substitute z is equal to 2 by 3, f of z become infinity, right? So that is a pole. So if you are having a pole, how to find residue? Residue of f of z is given by at z is equal to 2 by 3. It's a pole of order 1, simple pole. For a pole of order 1, how to find residue? That I posted on video on finding the residue, that is given by formula limit z tends to 2 by 3 z minus 2 by 3 into f of z. F of z is 1 by 3 into z minus 2 by 3, right? So how to find residue? What is the formula? Let me write that formula. Residue of f of z at z tends to a is given by limit z tends to a z minus a into f of z. Here a is 2 by 3, so z minus 2 by 3, f of z is given here 1 by 3 into z minus 2 by 3. So I have posted on video on how to find the residue. Please refer that. Finding the residue is important problem in TNEB exam. So this is cancelling. So when you cancel this, what we get is 1 by 3. So we got a residue as 1 by 3. But what is answer? My answer is limit integral dz divided by 3z minus 2 is equal to 2 pi I, because this see, I am going to apply Cauchy's residue theorem. So 2 pi into sum of residues. I have only one residue, that is 1 by. So 2 pi I by, this is the answer. Because Cauchy's residue theorem states 2 pi I into sum of residues, right? 2 pi I, residue is 1 by 3. Only one residue we have, so 2 pi I by 3. That is the answer. Simple problem. What about second problem? 2z square plus 2z plus 1 divided by. Okay. So I have little space, so I erase it. Second problem. Fine. This is one beautiful problem. Here you see, here I got residue, right? Here z into z minus 2 by 3, that we must see first. So pole at z is equal to 2 by 3, that is 0.6. 0.6 lies less than inside the circle. Z is equal to 1 circle. Here what we get is z is equal to 0.6. Pole at 0.6, so we can get 0.6 inside the circle. So as per the residue theorem, our z1, z2, all the points should lie inside the curve. So here curve is a circle. So z is equal to 0.6 as a circle, 0.6 lies inside 1. So we can apply residue theorem. But here you see, by seeing the question itself, we can say here is pole at 3. Z is equal to 3. Because when you substitute z is equal to 3, the function becomes infinity. Z is equal to 3 is a pole. What is this? This is x squared plus y squared is equal to 4. That means it is a circle equation. Because circle equation is x squared plus y squared is equal to r squared, with the center at origin. So r is equal to 2. So it is a circle of radius 2. Plus 2 here minus 2. But pole at 3. We have one pole at 3. That means the point lies outside the circle. So we cannot apply. The answer is 0. Directly you can write. No need to check. Right? So first step is you have to check whether the point pole is lying inside the curve. Here the curve is circle. Here also the curve is circle. Don't think that it is x squared plus y squared. That is equal to mod z is equal to 2 circle. Like that. Right? So they have twisted. Next question. Okay. This question is, this is third question. C integral C dz by 2z plus 3. So I apply residue theorem. So f of z is 1 by 2z plus 3. First we check whether this point lies inside the circle. So that I can take at 2 z plus 3 by 2. So what is the pole? Pole at minus 3 by 2. Minus 3 by 2 means the function becomes infinity. Z is equal to minus 3 by 2, the function becomes infinity. Minus 3 by 2 is nothing but 1.5. So 1.5 lies inside the circle of radius 3. So we can apply residue theorem. So how can we find? So C dz by 2 into z plus 3 by 2 is equal to 2 pi I into sum of residues at minus 3 by 2. So I have to find the residue at minus 3 by 2 only. Residue of f of z when z tends to minus 3 by 2 is given by limit z tends to minus 3 by 2 z plus 3 by 2, that is z minus a into f of z. F of z is 1 by 2 into z plus 3 by 2. So what will happen? This will be cancelling, so it is 1 by 2. So what is my residue? 1 by 2. So what is the formula? Answer is 2 pi I into, only one residue I have, so the answer is pi I, right? So this is the answer. Fine. So answer is pi I. So evaluation is pi I. Next to fourth question. Again, I'm running short of space. So I do write this. So let us see this. Right. Okay. So what about this? Integral. So this I can write as, so I want pole. I want to find pole. Then only I can apply residue theorem. So I change this format. I write this equation as e power minus z divided by z. Yes or no? Z power minus 1 is 1 by z. So that is 0. dz. So this implies f of z is equal to e power minus z by z. Clear? Okay. Now I want to find the pole. So this is what is the pole here? Here we have pole at z is equal to 0. So it is a simple pole. And we have to check whether z0 lies inside the circle z is equal to 2. Yes. So we can apply residue theorem. So what is the answer for this question? That is equal to 2 pi I into sum of residues. Right? So I want to find residue. Residue of f of z at z tends to 0 at pole 0. So that is given by limit z tends to 0 z minus 0 into f of z. F of z is nothing but e power minus z divided by z minus 0. Cancel. Z0 means it will become 1. So what is my answer? My answer is 2 pi I. It's here, right? The evaluation of integral 2 pi I into sum of residues. I have only one residue. What is that residue? 1. So it is 2 pi I. The answer is 2 pi. Simple problem. Right? For this, the answer is 2 pi I. Okay. Next question. Here, fifth problem, z by z minus 3 dz. So what is the answer? 2 pi I into sum of residues. What is f of z? F of z is equal to z by z minus 3. So pole at 3. We have pole at z is equal to 3. This implies what will happen? Okay, z is equal to 3. Right? What is the question? So now they have given mod z minus 2 is equal to 3 by 2. Right? Pole at z is equal to 3. When you substitute z is equal to 3, 1. So 1 is less than 3 by 2, 1. So it lies inside the curve. So we can apply residue theorem. So I have to find the residue at 3. So residue of f of z at z tends to 3. Apply Cauchy's residue. How to find residue? The same process. Limit z tends to 3. Z minus a is 3. So f of z is nothing but z by z minus 3. So 3 cancel is 3. Fine. So what is the answer? Answer is 2 pi I into sum of residue. I have only one residue 3. So 6 pi I. Right? So why I am doing all the things? Because what is Cauchy's residue theorem? Integral f of z dz is equal to 2 pi I into sum of residues. This is what my f of z dz. So 2 pi I into sum of residues. Sum of residue I found. Right? And the last problem is integral 3z square plus z divided by z square minus 1 dz. Right? So we have to find where, what is the question? The curve, let us see the curve. Z minus 1 is equal to 1. Z minus 1 is equal to 1. Right? This is a curve. Mod z. So first we will find pole 3z square plus z divided by z plus 1 into z minus. Right? First, what is the pole? We have one pole at z is equal to minus 1. When you substitute z is equal to minus 1, the function becomes infinity. So that is a pole. Another pole at z is equal to plus 1. When you substitute plus 1 here, it will become infinity. So we have one pole. We have to check whether all the 2 points are lying inside the curve. When you substitute z is equal to minus 1, what will happen? It will become minus 2. Minus 2. So that is equal to plus 2. Plus 2 is greater than 1. So this point doesn't lie inside the circle. So we don't need to mind it. That is equal to 1. 1 minus 0. 0 is less than 1. So this only lies inside the circle. So what I need to do, if I want to evaluate 3z square plus z divided by z square minus 1 dz, as per the Cauchy's residue theorem, 2 pi I into sum of residues. Even though we have two poles, we have to take only this into account. Right? So I have to find the residue at 1 only. So residue at f of z, z tends to 1. What is f of z? That is given by limit z tends to 1, z minus a, this is a, z minus 1, f of z is 3z square plus z divided by z plus 1 to z minus. This will be cancelled. When you substitute 1, it will become 4 by 2, that is equal to 2. So, what is my answer? So, 3z squared plus z divided by z square minus 1 dz is equal to 2 pi I into sum of residues. I have only one residue 2. So, that is. So, the answer is 4 pi I. Very simple problem. Clear? Okay, next. Sum of residues problem, I will give one more problem on my own. So, let us assume, okay, so 1 by z minus 1, right, minus 1 by z minus 2, this C, right, there is z by z minus 1, z by z minus 1, dz, right, I have to evaluate with the curve mod z is equal to, okay, this is 3, oh, let us take this 1, mod z is equal to 3, right, so what is the answer? So as per the condition, z by z minus 1 minus z by z minus 2 dz is given by 2 pi I into sum of residues, right? Okay, here pole at z is equal to 1, here pole at z is equal to 2. So z is equal to 1 lies inside 3, z is equal to 2 also lies inside the circle 3. So both are lying inside, so I have to find 2 pi I residue at z is equal to 1, residue of f of z, right, that we must remember, plus residue at z is equal to 2, right. I find the residue of f of z at z tends to 1, that is given by limit z tends to a is 1, z minus a, z minus 1, f of z is z by z minus 1, 1 cancel, z is equal to 1. So this is first residue, right. What about second residue? I have to find residue of f of z, sorry, f of z is full, right? Okay, this is what full f of z. F of z is completely we have to take. So otherwise, what I do, I change the problem like this. Please change the problem like this. Residue and all same. For simple analysis, I change the problem as z by z minus 1 into z minus 2. Z by z minus 1 into z minus 2. Like that I change. Right? So here also z minus 1 into z minus 2. So 1 by minus 1, that is equal to minus 1. Fine? Okay. Next, residue of f of z when z tends to 2. Limit z tends to 2, z minus a, that is a is 2, f of z, z by z minus 1 into z minus 2. Right? So 2 to cancel, z is 2, 2 by 1 is 2. Right? We have two residues. So what is the answer? 2 pi I into sum of residues. One residue is minus 1, another residue is 2. So that is equal to 2 pi I. That's what z by z minus 1 into z minus 2 dz. C. Right? I hope you understand all the problems. If you have any doubt, please ask me in comment section. I will clarify all your doubts. Thank you.